Example number 5. This will be our last example, section 6.3. All right, so directions are the same. Obviously a different question. All right, so asset allocation. A financer plans to invest up to $500,000 in 2 projects. All right, so project A yields a return of 10% on the investment, whereas project B yields a return of 15% on the investment. Because the investment in project B is riskier than the investment in project A, the financer has decided that the investment in project B should not exceed 40% of the total investment. How much should she invest in each project to maximize the return on her investment? What is the maximum return? All right, so first thing we're going to do is define our variables. All right, so I'm letting X be equal to the amount invested in project A and Y be equal to the amount invested in project B. Okay, let's go ahead and determine our objective function at this time. Our objective function is going to be based on this. Project A yielding a return of 10% and project B is yielding a return of 15%. Okay, so we're going to translate that into an objective function. And that objective function would look like this. We are going to be maximizing what? We're going to be maximizing this. Well, it's revenue, right? Or return. It's a return, I guess. Okay. So what's the return going to be equal to? Well, 10% of the amount invested in project A, which is X, plus 15% of the amount invested in project B, which is Y. So there's your objective model. The next thing we have to do is determine our restrictions. So this is where we write subject to, and then afterwards we write down our restrictions. Okay, well, the first thing it says here is that a financer plans to invest what? Up to $500,000 in 2 different projects. And we already defined those projects as projects A and B. So what I just underlined here in red would translate into what? Well, our first restriction would be X plus Y, right? That's the total amount we're going to be investing. Could be up to, which is less than or equal to what? Less than or equal to $500,000. All right. The second restriction we can come up with is based upon this statement beginning with because the investment. So because the investment in project B is riskier than the investment in project A, okay, the financer has decided what? The financer has decided that the investment in project B should not exceed 40% of the total investment. Okay, so what the heck does that mean? Well, let's translate. The financer has decided that what? The investment in project B. What's project B? Let's zoom in here. Let's get all fancy. Ooh. The investment in project B, which is Y, should not exceed what? 40% of the total investment. What's the total investment? Total investment is X plus Y. It's $500,000. Okay, so what does this really mean? It means Y cannot be greater than what? Well, let me say it correctly here. Y has to be less than or equal to this product, which is 200,000. All right. This is nice because this is just a horizontal line. Okay. The other restrictions we have to always include would be what? X is greater than or equal to 0, and Y must also be greater than or equal to 0. Okay. So the setup of something like this is hopefully the most difficult part, I hope. In other words, you got to be able to read and interpret what the given information is telling us, telling you, formulate your linear programming model, and then at this time, be able to graph this thing correctly, okay? Determine your vertices, plug them in that table, and then you're good to go, all right? So let's go ahead and do that now. Let's graph our first restriction. X plus Y is less than or equal to 500,000. Well, look, both the X and the Y intercepts are gonna be 500,000, right? I mean, you got an intercept right here at 0, 500,000, and you got one down here at 500,000, 0, okay? So let's go ahead and graph that line. I wish I had a straight edge. Somehow my ruler, my straight edge disappeared. And it certainly could not have been one of my kids. It just sort of magically disappeared. Anywho, okay, that's our first line. We just graphed this one. Let's look at our second line, which is this one, our second restriction. So Y must be less than or equal to 200,000. All right, so 200,000, this is going to be 100, 200, based upon how I'm scaling my axes. This is just a horizontal line, all right? So here's 200,000, Y equaling 200,000. I'm just going to go over to the right, like that, and look at this. Our point of intersection, well, hopefully we already knew what that was going to be. Because of what? We knew our point of intersection must be X equaling what? If Y is 200,000, then X must be 300,000. Good. So I'm going to go ahead and label this point as 300,000. Tell you what, I won't put a comma in there because it'll be confusing. Then 200,000. And this is going to be 500,000, 0. This point is going to be, if I can squeeze it in here, let's see, 1, 2, 3. Okay. And this point is going to be 0, 0. Isn't this exciting? All right, now based on the inequalities, we have to shade this thing correctly. So our first line right here, this is X plus Y is less than or equal to 500,000. We're going to shade this way, all right, below the line. Our second line was Y is less than or equal to 200,000. Less than, we shade below. So the intersection is going to be in this trapezoidal region right here. This is your feasible region S. All right? And so we do what? We come up with our vertex. Okay, let me zoom back out here. We come up with our vertex column. And we come up with our what? Our objective function column, which looks like this. And we go to work. So let's go ahead and put our vertices in there. And once we have our vertices in there, we determine our returns. So for this first corner or vertice, we would get what? 30,000 in returns. This corner or vertex would generate 60,000 in returns. This one would generate 50,000. And 0, 0 would, of course, generate nothing. All right, so again, we're trying to maximize our returns. So this is going to be our max. Again, it is a word problem. So let's answer it accordingly. All right, so therefore, what? You want to invest how much money in project A? So therefore, you want to invest what? 300,000 should be invested in project A. 200,000 should be invested in project B to do what? To realize a return of $60,000. Okay? I hope this is helpful. This is, again, not ideal. Try to hang in there. Keep trying to adapt. Try to stay positive. We have one more section to do. We'll look at that on Thursday. And then you have your next test coming up in less than 2 weeks. Okay, a week from this Thursday is your fourth test. All right? Hang in there. Hope you're staying healthy.